Hi everyone. Today we are going to do voltage, having done current in the last lesson. So voltage is measured in volts, okay, and it's measured by a voltmeter, which we see here. This is a voltmeter here, and voltmeters are connected in parallel. The reason they're connected in parallel is because voltage is potential difference. So it measures the potential between 2 points. So that's why it's in parallel. So between here, this point here and this point here, it measures its potential. Okay. So we know then that voltage is potential difference. In the last lesson, I used the equation for current quit. Charge equals current times time, or current equals charge over time. Now I didn't use the VRI equation. Okay. Because I thought I'd wait for this and just give you one equation per lesson. So this VRI equation, the triangle makes it much easier, is that you can measure voltage by multiplying resistance times your current. Or if you wanted to measure current, you would say current is equal to V over R, because R is at the bottom. These triangles make it very easy, and if you wanted to measure resistance, it would be V over I. So that's all good. Now, you can't just plug into the equation blindly with these circuit problems, because sometimes voltage doesn't behave in the same way. So in other words, if you had voltage in series, or voltage does, let me put it, voltage doesn't behave in the same way that current does. In fact, it's almost the opposite. So current is the same at the beginning of the circuit, at the end of the circuit, whereas voltage gets used up in the circuit. So what I want to do is I want to show what voltage does by using different colors. So let's look at voltage when it comes out, okay? It hasn't encountered any resistance, so it hasn't been used up. When it hits this resistor, which I haven't actually given a value to, which I need to do quickly. So let's make it 2 ohms. It hits this resistor and some of the voltage gets used up. You can think of, so when we looked at current, we thought of it as flowing like water, okay? If we think of voltage, we can almost think of the thing that's pushing the water along, but it gets tired. It doesn't have infinite, it's not a finite, it has a finite amount. So it gets used up in the circuit, and we can think of it as getting used up until the very end, where it gets back to the battery, and then the battery then provides more oomph to push the water along its way. So we look at the voltage now. It's now different when it hits the when it's left the 2 ohms, so it's been used up. It's now purple. Now, what happened to current when it hit these parallel resistors is it split into 2, like water. It's split into 2 directions. Voltage doesn't do that. Voltage is the same in parallel, across parallel. So these 2 voltmeters that I've drawn here, V2 and V3, have the same, measure the same voltage. But obviously, when it's gone through these 2 resistors, some of the voltage has been used up. Okay, and then now more voltage gets used up across the 7 ohm resistor. And now it's back at the beginning. So when we look at these colors, if you draw the colors in the circuit, if you have time, you can then know what voltage is being measured. And you can see, if I was to draw a voltmeter, so Let's say I drew a voltmeter over here. Okay, another voltmeter. We see that it's measuring the pink and the purple potential difference. So we know that this voltmeter here would be the same as V1 because they're both measuring the voltage across the battery. Or you could think of it as measuring the voltage across the entire circuit. V2 and V3 are the same because they both are measuring purple and green. So we know that V2 equals V3. We also know that if we were to put a voltmeter, say, across here, across the 2 ohm resistor, V4 would be greater than that voltmeter because it's a higher resistance, meaning more voltage is required to push the water across that resistor. So, voltage, let's recap. Voltage is potential difference. It's measured in volts. It stays the same in parallel. It gets used up along the circuit. And we can calculate voltage by multiplying resistance times your current. There are other equations for voltage using power, which we will do in another lesson. I just thought I'd do one equation per lesson so that we don't bombard you too much and make it too confusing. So the next lesson, we will be doing resistance. Have a great day.